Okay, we are going to start on power now. So we talked about work, and we talked about how work takes energy. Well, power is the rate at which work or energy is done. So whenever you say a rate, you have to include time. So power is equal to work divided by time. All right, now I'm going to break this down a little bit more for you because it doesn't on here, and I kind of wish it would. So remember that work is equal to force times distance. I just took this right here, this work, and I just plugged in force times distance. So that's another way to write the equation for power. And then there's a third way. Remember how we didn't have force on that example 3.1, and we had to use weight? And remember, weight is mass times gravity, but we still have to use distance here because this is for force. Okay, there we go. And then time. That looks really bad as far as, let me see. I don't know. My stuff isn't working. It's so annoying. So it's mass times gravity times distance divided by time. And power is measured in watts. Okay, so kind of like when you go to the grocery store and you get light bulbs and they're in certain watts. Okay, so that's gonna kind of make sense, right? Power. All right, so those are 3 ways in order to do your power equation. And so in the metric system, we use watts, but in the English system we use horsepower. So if your vehicles and stuff are measured at so many horsepower. An example is like walking versus running upstairs. So in class, students like hybrid, one of our labs is going to be walking and running up the stairs. It's a really actually fun lab. People are always like, I'm like, really? You just have to walk up the stairs. But anyway, and what's really cool about, power and stuff is you can actually break down your electric bill, and you can figure out how much you're paying for lights or your refrigerator. And honestly, lights and stuff really aren't that much for the most part. Now, if you leave them on all the time, that's going to add up. So, yeah, I have an example that we need to do here. Okay. Let me bring up my notes. Oh my gosh. It's not what I wanted to do. Why is everything so difficult? All right. So we've got example 3.3. This is saying an electric lift can raise a 500 kilogram mass a distance of, I need to write that down, 500 kilogram mass a distance of 10 meters in 5 seconds. What is the power of the lift? Okay, so we know that power is equal to work divided by time. So work is measured in joules and time is measured in seconds. Do we have anything up here that is in joules? No. So remember how I said we might have to break it down into, there's 3 different equations? All right. So let me erase this really quick. Hopefully that didn't confuse you when I did that. So I said it could also be broken down into that equation. Well, force is measured in newtons, and distance is measured in meters, and time is measured in, not time, it's measured in seconds. So do we have anything up here that's measured in newtons? We have something that's measured in meters and seconds, but not newtons. So we got to use that third breakdown of the equation. which was mass times gravity times distance divided by time. All right, now looking up here, do we have all of that information? Yes, we do. We have 500 kilograms. We know the gravity is 9.8. Don't leave that out. We know the distance that it was raised was 10 meters. And the time that it took to do that was 5 seconds. Okay, so if you go through and multiply 500 times 9.8 times 10 divided by 5, you should get 9,800 joules per second. Okay? Now, if you look on the example here, it goes and it puts it into kilowatts. You don't necessarily have to do that unless your homework is specifically asking you to do that. So 9,800 watts is fine. If it does ask you to do it into kilowatts, just do your dimensional analysis. You've got watts to kilowatts. So for every 1 kilowatt, there's 1,000 watts, right? So which makes it 9.8 kilowatts. And then another thing that it does is it says it goes ahead and it converts it to horsepowers. So again, it would be pretty specific in the example or the homework problem on if it wants it in watts, kilowatts, horsepowers. So if it wants it in horsepower, you're going to have to do dimensional analysis again, and you should get about 13 horsepowers. Okay? So anyway, that's how you can do those different conversions. All right. I'm not going to do example 3.4 because, again, it's using those English system units. I don't really like that. I don't really like that it's doing that. So we're just going to focus on ones that are like example 3.3, okay? Those are the kinds that are going to be in your homework and on your test. All right? All right, so go back to the PowerPoint here. And I'm going to stop it because this is getting us into potential and kinetic energy.